A new model just dropped. You might be hoping it finally fixes the two fears that stop engineers going all in. The agent says it is done. But how do I know it is not just slop? And what happens when my org realizes I am not the one writing this code anymore? I watched 10 hours of Anthropic's London 2026 conference for the answer, and the punchline is this. The new model is not what fixes this. The teams shipping at scale, Delivery Hero merging 173 pull requests every day, Spotify cutting a JVM migration from months to 3 days, the team that rewrote Bun to Rust in a week, are all running the same 9-step harness. The first move is the one I was most resistant to, and the one that changed everything. The first move, and the one I was most resistant to, is to build an eval before you touch the prompt. Margaret Van Laar from Anthropic's Applied AI team puts it like this.
We need a starting point, and that starting point is evaluations. We need evaluations to provide that rigor to understand whether a change to our prompt is actually correlating to an improvement in its performance.
Prompting can fix the second case, but it cannot save you from the first. That is the line your eval has to draw for you. Take a customer support team. They pull 30 real tickets in one category, and for each one, a senior rep writes the reply they'd consider a good answer. That labeling, deciding what good looks like, is the actual work. The rest is a script. Then your LLM composes a reply to each ticket. A second LLM judge reads both, the human one and the AI one, and picks which would resolve the ticket better. You track the win rate. Maybe the AI beats the human on 73% of tickets. That's a number you can act on. Tweak the prompt, rerun the same 30, see if you climb to 80. Without that loop, every prompt change feels good in the moment, and you can't tell whether you regressed on cases you didn't think to test. What surprised me is how small the eval starts, because it is just 5 cases to begin with. 1 control case, the model always passes, 2 or 3 edge cases, where you have already seen it fail, and 1 capability boundary case that tests whether it knows when to hand off to a human. That is your unit test suite for the AI era. And as Jeremy, a product manager on the Anthropic research team, says, every application that uses AI should have one. The maintenance habit is the part most teams skip. Once you are live, you need to pull real user traces back into the eval set, because otherwise the eval saturates while production keeps breaking. Lucas at Anthropic calls this silent saturation, where your dashboard says 100% green and your users are still hitting the same wall as before. Once the eval exists, every move in the rest of this video gets easier, because plan first becomes measurable, model upgrades become a rerun instead of a guess, and autonomous loops have a fitness function they can hill climb against. Without an eval, you are just changing words in a paragraph and hoping that it sticks. That is why this is step 1. Step 2 builds directly on the eval, but it changes when you let the agent make decisions, by inserting a plan first step before any code gets written. Jacob Emmeling, a staff software engineer at Legora, puts the why in a single sentence.
A bigger task together with Cloud Code, or your coding agent of choice. You start, instead of just like firing off a prompt and let it rip for a few hours, you start off like planning like a detailed plan of how the work should be done. And this basically solves a few different things. First of all, you're exploring the problem together with the agent, you're gathering a lot of context, and you're also making upfront decisions so that then the agent doesn't need to make decisions for you when it actually executes the work. And yeah, it turns out this works exactly the same way in legal, if you wanted to.
And the cost of skipping that step is what makes it worth bolting on. A few hours to bolt on. Irreversible if you skip. On Google Cloud, Ivan Nardini showed this live, building a feedback app end-to-end.
Like components that you can find in Claude Code, which is the planning mode. So probably most of you are familiar with it, but with the planning mode, Claude, like this mode puts Claude in a mode where he thinks and he proposes before he starts coding. And this is very important because it gives me some degree of freedom to decide what to build before Claude start building based on my personal preference. So with that being said, let's jump in the second demo.
That degree of freedom is what Plan First buys you. Here's what that looks like in practice. You write a prompt. Claude proposes a numbered plan instead of code. You edit the parts that miss your intent, and only then does it touch a single file. The pattern shows up in every talk where someone is shipping at scale. The cheapest moment to redirect an agent is the moment before it spends tokens. The next cheapest moment is never. Step 3 lives on a different layer. Because where Plan First separates planning from execution at the workflow layer, the advisor strategy does the same separation at the model layer. The cleanest version comes from Puneet Shah on the platform Deep Dive.
It encounters this sort of weird oddball shape, and it doesn't know what to do this, and it just calls the advisor, asks what to do, and then it gives it advice on what to do. The insight here is if you've ever worked with development teams, you've probably noticed there are senior engineers paired with junior engineers that make that junior engineer so much more powerful. That junior engineer is still the person hands on keyboard getting work done, but with the coaching, the mentorship, the code reviews, the help on architecture from the senior engineer, they're able to actually achieve so much more than they otherwise would have, sometimes even approaching what someone with that senior engineer skills could have done solo. And that's the kind of same idea here. It turns out that same logic works with models, that pairing the kind of Sonnet Haiku gets you kind of the prices of those models approaching even sometimes Opus intelligence, a big intelligence boost. And folks like Bolt have used this. They've kind of gotten better architectural decisions where they can see on complex tasks, it improves performance, while on less complex tasks, it has no extra overhead. It just doesn't call the tool. And so it's a pretty nice trade-off. It's like a Pareto optimal way to improve your cost and intelligence performance.
And wiring it up is a 5-minute change. You add Opus to the tools array of your messages API call, alongside the other tools your agent already has. The executor calls the advisor only when it hits an unfamiliar shape. The rest of the time, it works at executor speed and executor cost. Here is the curve Puneet just named. Sonnet alone sits at high cost and middling quality. Sonnet calling Opus moves down and to the left. Lower cost, higher quality, fewer turns to finish. Eve Legal told the keynote team this.
Cheaply than on its own, because Opus advised it to get its work done better. Eve Legal, for example, used the advisor strategy, and they told us they got frontier model quality at 5 times lower cost.
And that's awesome. This is a perfect situation where you can apply it to a freemium model.
Cheaper option that also performs better. Puneet then ran a live demo on what he called a watermelon. Green and healthy on the dashboard, red and rotten when you dig in. Sonnet alone confidently shipped the watermelon. Sonnet calling Opus as advisor caught it. The advisor strategy is a quiet move, but the 2-line API change buys you a different cost curve. Step 4 is about the shape of the harness, and the conference talks split it into 2 layers, the loop inside and the orchestration on top. The loop layer comes from Jacob Emmeling at Legora. He ran an experiment that convinced his team.
And it just kept started editing paragraph by paragraph as you would expect. Then sometimes it got a bit lost, started rereading the whole thing, sees, oh, I forgot a paragraph up here, goes back, edits the paragraph, and just keeps doing this for like 10 minutes. And at the end, we opened up the document, and everything was translated. And the funniest part about this was that to test how good this new harness and tool design works, we run this whole thing on Haiku, so this wasn't even a good model. And I think this was really a moment for us where we realized, okay, this might actually work. There might actually be something about mirroring tool design from coding agents and getting a lot of benefits from it. And I think the interesting part here is that, or like my mental model is kind of that you want to have the model almost feel like it's inside a coding agent harness and it just does a legal task. Because then...
So that is the loop. The loop primitives are read, edit, verify. The same shape every coding agent has converged on. The orchestration layer on top has its own consensus, reached in the lightning round of the enterprise scale panel. Many specialists orchestrated by one generalist. The generalist roots work, and the specialists each have a narrow tool set and a focus prompt. Ruslan from Monday.com built their Vibe product exactly this way. Opus as the orchestrator on top of cheaper models, executing the sub-actions. The managed agents talk pushes this further. You give your main agent access to other agents as tools, and Claude decides at runtime when to spawn them. But on the orchestration layer, there is a contrarian. Lucas, applied AI at Anthropic.
My kind of hot take here is people spend too much time thinking about these like super complex multi-agent orchestration systems and not enough time doing the simple thing that works, which is just like good context hygiene and good context engineering. So
by restructuring tool output for a Premier League scores agent from verbose JSON to compact Markdown, his team cut token usage by 66%. A web search use case that deduplicated articles cut input tokens by 77% and bumped accuracy by 9% at the same time. So who is right? Both are, because they are answering different questions. Jacob is answering what shape the loop should have. Lucas is answering whether you need the orchestration layer at all yet. The combined recipe? Shape the loop like a coding harness, but before you reach for a 5-agent topology, restructure your tool output and see how much of the problem disappears. Step 5 is where context becomes the entire game. Step 5 picks up where Lucas left off in Step 4. If context hygiene beats orchestration on the priority list, then the question is, what context to expose and how to lay it out? The thesis comes from Tara Fernando, head of data and AI at Man Group.
Out of the box, Claude is an amazing general-purpose tool. It does a lot, but it doesn't know us. It doesn't know our data. It doesn't know our systems. It doesn't know how we work. And it's the same for everybody in this room. So the first thing that we had to do was teach it. Not by retraining it, not by doing fine-tuning, but by giving it access to our data, our capabilities, and our workflows.
Frontier Labs will keep improving the base model. They cannot solve organizational context, because that context is not on the internet, and they do not know your workflows. Your moat is what you connect, not your data alone, not your MCP alone, not your skills alone, not your workflows alone, what flows through them. This is the cleanest reframe of the era shift in the whole conference. Your moat is what you connect, not what you fine-tune. Data, MCP, skills, workflows. The model sits at the center, and your edge is the wiring that feeds it. Before you optimize anything, you have to look at what the model is actually seeing. Puneet Shah, product manager on Anthropic's platform team, repeats this 3 times in his own talk.
What we need is context engineering. And what context engineering is the art and science of figuring out what context you expose to Claude to give your agent the best performance. And again, I said this earlier, I'm going to repeat it many times. Look at your transcript to see it, to see what the Claude, the models are actually seeing. And that will, I think, be incredibly illustrative to see, is there a lot of stuff that you really don't need to be passing to Claude? Or is there a lot of relevant stuff that's keeping it on track? And we'll go through today, there's many techniques, we'll go through kind of 3 primary ones about how you can implement better context engineering on your models.
Most of his team's context engineering wins came from spotting junk in transcripts that should not have been there. Giant unfiltered tool results, redundant system prompts, a full meeting transcript when only a sentiment score was needed. You cannot judge whether your tools are well-shaped until you see them in context. Then there is the layout move, which Daisy Hollman from the Claude Code team frames around the KV cache.
I think it made more sense when we had 32,000 token context windows, maybe, and like all of the tokens were expensive no matter what, and like KV caching wasn't as efficient, but like none of that's true anymore, right? You should think of these tokens as cheap and these tokens as expensive, right? And you're going to pay a whole lot for a lot of expensive tokens.
The naive instinct is to prune the oldest stuff first. That instinct is exactly backwards. Change one token early in the prompt, and every cached token after it gets recomputed. The cost difference is roughly 10 to 1. Pin stable shared text at the very front of the prompt, where it never moves. Let volatile per task scratch live near the end, where it can be evicted cheaply. That ordering is what changes how you architect prompts permanently. The era shift this step describes is the move from teams trying to retrain the model on their data to teams treating the model as a constant and investing all their effort in what flows through it. Budget for context engineering instead of fine-tuning, because the leverage has moved. Step 6 is the move that everything autonomous in this video depends on. Before you let an agent run overnight, before you turn on auto mode, before you spin up parallel sessions, you build the verification loop. Without it, you are pointing a long-running agent at a task with no way to grade its output, and what you will get back is plausible-looking slop. Sid Bhattacharya, a founding engineer on Claude Code at Anthropic, defines the loop crisply.
And this is arguably the most important slide in this presentation. So if you haven't been paying attention yet, this is the good time to get started. A loop essentially is an autonomous circuit that you can complete for Claude. And it allows Claude to hill climb on a given task or a given success criteria. So you can think about it as giving Claude access to tools to verify its own work and to write code. And what Claude will do is it will write some code. It will check if there's a failure. If there's a failure, it will debug that failure and write some more code. And then it keeps doing that in a loop again and again and again until it gets to a success state. And when it finally gets to a success state, you can be confident that the PR that it's sending you is higher quality and will actually work.
That shift, from one-shot prompting to looping, is the shift from you being the Q&A pass to the environment being the Q&A pass. 2 iterations. Write, check, fail, debug, back to write. Then the second pass. Write, check, pass, exit. He then gives you the 4 primitives you actually need to build, regardless of stack.
But I wanted this slide to be a little bit more concrete. So what does it actually mean to give Claude the instructions and the tools to make it go in a loop? And it usually boils down to like 4 things.
Run the app, drive it, prove a state change, and unblock auth or seed data. For a front end, that means spinning up the dev server, driving it with the Chrome MCP or Playwright, taking before and after screenshots to prove the fix landed, and shipping the auth and state seeding scripts so Claude can log in and populate the inventory. Niklas Gustavsson, chief architect at Spotify, has the institutional version of the same idea.
And we think this is super useful both for our developers and for our agents. And we see this all the time. As when I work with Claude in our code base, I will see Claude run into these lint checks all the time and correct itself. It's an awesome way to drive this type of standardization. All right, I'll try to sum this up. So first, hopefully this came through, but the need for strong engineering practices has not gone away with agents. It remains as important as it was before. Boris mentioned verification this morning. We fully agree with that.
The lint rules are doing double duty. They enforce convention on humans and act as an inline reward signal for the agent. Anything you currently catch and review should become a lint rule before you blame the model. Jeremy on the Anthropic research team framed the principle as a single question to ask before you point a long-running agent at anything. What gives this agent ground truth? If the answer is nothing, you get slop. But if the answer is a test suite, a benchmark, a type checker, a property fuzzer, or a production canary, let it run for hours. No verifier, no autonomy. What if the agent could just keep going without asking permission every 30 seconds? Step 7 is the gate that unlocks everything in steps 8 and 9. Without auto mode, your agent stalls at a permission prompt every 30 seconds, waiting for you to type yes. With auto mode, it stops being a co-pilot you steer and starts being a background worker you check on. Watch the difference. Same session, one stalls on permission prompts, the other runs through. Ralph, a member of the Anthropic technical staff on the What is New in Claude Code talk, explains the mechanism.
What auto mode is doing is first leveraging the high capability of the latest models as well to assess if a situation is destructive or not. Because what auto mode does is that for every time where otherwise Claude will stop and go to and say, hey, can I get permission for this bit? Auto mode checks that with a classifier that checks two things. So the first thing is this action destructive? Am I going to regret this down the line? So yeah, that's the first check. The second check is pretty much, does this look like a prompt injection? So yeah, is this part of the situation that looks like that is going to inject something on my prompt? So if the checks passes, so none of this is true, Claude takes the action on your behalf. So it doesn't stop and it continues running. If any of those checks fails, what happens is that Claude will try to find a workaround, maybe.
So that is the policy. 2 checks per tool call, and only the ambiguous calls bubble up to you. Destructive? Prompt injection? 2 gates between every tool call and execution. Pass both and Claude proceeds. Fail either, and you get pulled in. Daisy Hollman, from the Claude Code team, is direct about how foundational this is.
It has a lot of instructions. It's basically no more permission prompts. This is what makes Loop usable. This is what makes agent teams usable. This is what makes overnight work usable. It's a little expensive. It can be on the order of 30 to 40% more because you are like using quite a lot of extra tokens. I don't actually know the number off the top of my head, so don't quote me on that. It could be less than that now. We're working on getting it down. Claude agents, we just launched. I know I'm running out of time, but give me like 2 more minutes. Claude.
The honest cost is the extra tokens the classifier spends evaluating each command for danger. And as Daisy flagged, that cost is steadily coming down. The trade converts agents from interactive co-pilots that need you in the room to background workers that finish jobs while you sleep. Auto mode is not dangerously skip permissions, the flag you may have reached for while debugging. Auto mode has the classifier plus an adversarial checker underneath, and almost every software engineer at Anthropic uses it for everyday work, because the safety infrastructure is doing the gating instead of you. Now the disagreement, which is about how far you should push parallelism once auto mode is on. Daisy and Ralph both point you toward many simultaneous sessions, because that is what the unlocked async patterns enable. While Sid Bidasarya, the founding engineer of Claude Code, pushes back from his own practice.
The problem that arises when you try to run too many Claude instances at the same time is that they all eat at your attention, and your attention is a scarce resource. I personally find that more than 4 to 5 sessions open simultaneously takes a big load on my brain. And
So who is right? Both are. The combined position is to turn auto mode on as a hard prerequisite for the next 2 steps, then test where your own ceiling actually sits, because it probably is not at 1, and it probably is not at 20. Step 8 is where Claude runs without you in the room. Step 8 is the move that takes the loop off your keyboard. The endpoint of your work stops being a chat response and starts being a merged pull request, or a rendered document, or a deployed change. The agent runs without you in the room, and you become the person who reviews the result. A merged pull request, a rendered document, a deployed change. 3 endpoints, 1 reframe. The deliverable stops being text in a chat window. Boris Cherny, the Claude Code lead at Anthropic, names the reframe.
A lot of my code these days is written by routines. I'm not the one doing the prompting. I'm the one that creates a routine that does the prompting. For the engineers in the room, think of it like a higher order function. Routines are a higher order prompt.
Routines are a higher order prompt. You write the function once, and it fires every time the trigger condition holds. One definition, many firings. A cron tick, a webhook, an issue opening. Each one calls the same routine, and each one drops a pull request on the other side. Maya, on Anthropic's applied AI team, gives you the 3-decision framework you need to design any routine.
The second decision is, what context or what information does Claude need to have to actually be successful here? Do you need access to certain docs, or does Claude need access to certain tools to ping you? Finally, the last thing to think about is, how do you actually steer Claude in the session to keep it honest? How do you guide Claude to the output that you want? And so we'll dive into each one of these, and I'll talk through how Sarah, a member of our team, actually does this to automate documentation creation.
Skip any of the 3, and your routine either fires at the wrong moment, hallucinates from missing context, or silently ships bad work. Pick the trigger that matches the natural cadence of the work. Load every repo, connector, document, and tool the agent needs. And keep the routine honest with agent-on-agent review, mid-session human steering, or post-run rendering checks. Uruk Shifa, VP of Tech Foundations at Delivery Hero, described the production version on the enterprise scale panel.
And we decided to try out to build basically an agent that takes a Jira ticket or a GitHub issue and takes it to production readiness in terms of a pull request that can then be merged.
They call it HeroGen. Ticket in, PR out. Running since February. Here's what HeroGen does end-to-end. A Jira ticket enters. HeroGen picks it up, reads the repo, drafts the code, opens a pull request. CI runs green. A reviewer approves. The change merges. The engineer never typed a line. The result is the 173 merged pull requests per day you heard in the cold open. This is what Step 8 looks like in production. About 7,000 PRs total since February, and the trajectory is exponential. Step 9 is the reframe of what your job actually is now. Step 9 is the maintenance habit that closes the loop. When a new model ships, you do not just swap it in. You audit the scaffolding you built around the old one, because some of it is now actively misleading the smarter model. Jeremy on the Capability Curve talk gives this its name, the Frankenstein prompt.
Over time, you develop this huge Frankenstein prompt. I've been there, and essentially, as you develop your agent, you realize some failure, you add some line to the prompt to adjust for that failure, and eventually, you have 3,000 lines of mostly prompt instructions that were designed for previous models and for failures that might not even happen anymore. And so what you want to do is, when you get a new model, you want to cut down your prompt, figure out what's not necessary anymore.
New models follow those instructions more literally than old ones did, which means the workarounds you wrote for a previous model's failure mode now produce wrong output on the new model. Anthropic found a stale citation format example in the Claude.ai system prompt that was producing wrong citations, and deleting a few characters fixed a whole error class. Ruslan from Monday.com on the enterprise scale panel goes further.
For example, when we migrated from Opus 4.5 to 0.6, I think that was quite a change because, yes, it brings all these amazing capabilities, but at the same time, all the system prompts we've been optimizing so far just didn't transfer well, right? It was completely different beast, and it was it requires us like literally to go and rethink and fine-tune prompt techniques for this new orchestrated work and maximize its value for us. We actually worked, our team worked heavily with solution engineers from Anthropic that actually really helped to go like into depth and like really understand the best practices there.
His team now treats every major model release as a completely different thing that needs to be reharnessed, not a swap. Smaller releases go through standard end-to-end evals and A/B test in production, but major releases get the deeper rebuild. Fabian Hedin, the co-founder and CTO of Lovable, has the cleanest version of the pruning discipline.
Or the knowledge that we had kind of saved away in our corpus is actually included in the training data now, and it's no longer needed. And in that case, we also want to prune that from the corpus. So
when a new model ships, three things happen at once. Some entries you wrote for the previous model are now in the new model's training data, so they are redundant and you should delete them. Other entries assume the previous model's prompting style and now misfire on the new one, so they need rewrites. And the underlying packages your knowledge corpus describes may have moved on independently, so the content itself may be stale. Track success per entry before you scale the corpus, and prune ruthlessly on every model swap. Pulling all 9 steps together, you build the eval, you plan before you implement, you pair the executor with the advisor, you shape the harness like a coding harness, you expose your context, you wire the verifier, you turn on auto mode, you move the loop off your keyboard, and you prune the scaffolding when the model upgrades. None of that is typing code into a file. That is the job change, and that is the answer to the question the cold open opened with. The fear that your org will realize you are not the one writing the code anymore has the wrong subject, because your job is no longer to write the code. Your job is to build the harness that writes the code, and to keep it healthy as the model underneath gets smarter. Every team shipping at scale at this conference has already made the move from typing code to operating the harness. The 9 steps are how you make it too.